So we left off comparing the different types of bones. In this video, we'll go through different parts of the compact bone. So the compact bone is primarily made out of these things called osteons, which are these little tree-like structures here. And these are all the different components. We'll go through each of them individually. So osteons, like I said, are these little circular components. They run parallel to each other. So they are kind of like a bunch of straws in a glass. They're all parallel and they all have little holes in the center. One of the most important things is this thing called the central canal. So central canal is a passageway for blood vessels and nerves. This is how blood vessels are able to provide nutrients, get rid of waste, how nerves are able to sense any damage to the bone. You might also see this called the Haversian canals. I primarily will call them central canals. The concentric lamellae are little rings of bone that surround the central canal. You can see some of them go diagonally one way, some go the other way. This just increases the strength. Osteocytes are these little black dots here. These are the little cells. The little tan finger-looking things are the canaliculi. Osteocytes are immobile because they're trapped in that region, but they are sensing how much the bone is being strained. The little lacunae are the spaces that the osteocytes rest in. Canaliculi are the little canals that connect the osteocytes. They are connected via gap junctions, which allows the direct exchange, nutrients, minerals, gases, waste, and communication signals. Perforating canals. I'm actually going to go back up to this first picture. So we can see here the central canal that has the blood vessels. Those are running parallel to one another. So all these central canals just run straight up and down. So we need a way to get outside of the bone. We need a way to go horizontally. So that's why we have these perforating canals. So they connect the central canals together. You might also see them called Volkmann canals. The circumferential lamellae are these little rings of bone. So here, like number 4, is the periosteum. Just underneath that are these circumferential lamellae. And their goal is just to enlarge the circumference of the bone. So the more you use your bone, the larger they get in terms of circumference, even as adults. So that is where bone growth is happening. And we'll go through that later. Interstitial lamellae, these are the little spaces in between the osteons. You can see kind of right here where number 2 is. They're not complete osteons, they're kind of incomplete osteons, but they're there for structural support. This is just a picture. You can see an osteon here, central canal. Same thing. This is spongy bone on the bottom. This is just another picture for you to look at the different pieces that will expect you on the exam to be able to label and know the functions of each of the parts of the osteons. So circle the osteons. So those are the circles. Put a star in the Haversian or central canals. Okay. And then a little box on the interstitial lamellae. So spongy bone is made a little bit differently. There's no osteons. It's all trabeculae, and it's very resistant to stress. So you can see here, this is your tibia. You can see the outside compact bone. And then here's the spongy bone on the inside of the diaphysis. And then the medullary cavity is the part in the middle here. So the trabeculae are the little lattice structures here. Trabs means like a beam that holds your house up. Bone marrow is hanging out within here. and then the parallel lamellae. So this allows the osteocytes to rest and nutrients can come in. Spongy bone is very resistant to stress. So ossification is a process of forming hard bone. This starts in embryonic development. The two different types, there's intermembranous and endochondral. So intermembranous is forming flat bones of the skull, face, jaw, clavicle. Endochondral is everything else. So there are 4 steps to intermembranous ossification. The first step is these ossification centers form, then the osteoid gets calcified, woven bone and periosteum form, and then the lamellar bone comes in to replace it. And we'll go through all of these on their own. So step 1, ossification centers form. So they form within a thickened region of the mesenchyme. Here the mesenchymal cells will differentiate into osteoprogenitor cells, which eventually develop into osteoblasts. And osteoblasts secrete the osteoid tissue, that's that soft, gooey stuff. Then the calcium and phosphate crystallize, and they kind of stick the osteoblasts within themselves, and then they become osteocytes once they're trapped. From there, this woven bone forms. So it's kind of an immature type of bone here. You can see it kind of weaves in and out. You can see little osteocytes here with their little canaliculi to communicate. Then the periosteum forms, which is the outermost part. And then these blood vessels come in and they invade the woven bone. Step 4, this lamellar bone comes in and it starts to form a mature type of bone. And then the ossification starts to form compact bone on the outside. And then the inside, the trabeculae get a little bit modified to form what we know as spongy bone. Okay, so this is all of those steps laid out here. And remember, this is like flat bones of the skull. The other method is called endochondral ossification. This happens in 6 steps. So first, a cartilage model develops. Then the cartilage calcifies and we form a bony collar. Then first we form a primary ossification center, then a secondary ossification center, and then bone goes through and replaces all cartilage. And then lengthwise growth actually continues until like age 17 to 25, depending on how long. So step number 1 occurs in 8 to 12 weeks of fetal development. So the cartilage makes its matrix first, so these chondroblasts are secreting the cartilage, and then they form a perichondrium, which is kind of like the periosteum, but it's cartilage, so it's on the outside here. Step number 2, the cartilage calcifies, so it gets firm, and then this bony collar forms around the bone. So on the inside, the cartilage starts to deteriorate, chondrocytes die, blood vessels come in. When the blood vessels come in, they bring with them the osteoprogenitor cells, the stem cells that turn into osteoblasts, and then osteoblasts start secreting osteoid tissue around. And then we get the formation of the primary ossification center, which is in the center of the bone. And this extends, it starts growing towards either end of the bone. The secondary ossification centers form in the epiphysis, so they form at the ends of the bones. Vessels come in, osteoblasts secrete osteoid, and then the osteoclasts start to dissolve the very center of the bone in order to make the bone marrow cavity or the medullary cavity. Step 5, the bone is replacing cartilage. So everywhere except the articular, which is the ends of the bones, and the epiphyseal cartilage. Everything else is getting ossified. So when someone is born, a lot of their bones are still cartilage. So like when babies are learning how to walk and they fall, they aren't breaking a bunch of bones because they're still pretty bendy cartilage. They have a lot to give. They're more flexible than adult bones. And then you can see this girl's, 5 years old-ish, and she still has cartilage in her growth plates because she'll need that to continue growing. Okay, and then lengthwise growth continues until the epiphyseal plate closes. So these hormonal changes that you go through during puberty cause the growth, and then that causes the epiphyseal plates to close. And then after that, adults just have a line instead of the cartilage. So here are those steps for you again. So what areas of cartilage are left in or on the bones of a 3-year-old? So they have articular cartilage, which is on the end of the bone. Then they have epiphyseal plate cartilage, which is between the primary and secondary ossification centers. And this is the site of elongation. What about in the 28-year-old adult? So adults will only have the articular cartilage. They won't have any epiphyseal cartilage remaining. Okay, you can see here partial union. So this is the epiphysis, and then here would be the metaphysis. Here you can also see that. So this on this side, these are open, so this is someone who's less than 10, versus this there's partial closure, so this is someone that's reaching adulthood. So yeah, somewhere between 10 and 25, and then on the right, less than 10. Okay, I will pick up with bone remodeling on the next video.